So see this basically what I'm trying to explain here. So we have this equation basically we try to make, that is yp is equal to w naught plus w1 into x, right? And we have already this data x and y. So what we try to do to make a relation between x and y, we take some random value of w naught and w1. So you can take any value of this. Maybe I am taking 2 and 1. So my equation will become now 2 plus 1 into x. Now what I try to do, I try to plug in all these x value in this yp. So and we got every value yp for each value. Okay. So now here it will be yp. Let me open my ppt again and let me share this. Then we are able to understand again. Okay, let's do. See this case. Here you can see I make this equation 2 plus 1x and I plug all these x value in this equation. So we got this yp, right? We got this yp here. If we plug all this value, so we got these values. Here you can see there is a gap between the real value and the prediction because you are predicting using this equation. And in this equation, we take W naught and W1 totally random. Okay. So see there the difference. So here we can calculate one loss function. That loss function is basically what is the gap between the real value and prediction. So here we have yp minus y, or we can take y minus yp for each data, and then we can take average. Here we are taking the average yp minus y, then adding all the loss, then 1 by n. So it will be average of the loss. But see, there is a problem with this equation because no one can guarantee yp minus y will be always positive. Maybe it's negative. Let me explain you how it's become negative also. See, suppose you are taking yp minus y summation and average. Sometimes maybe this yp minus y maybe minus 2, 3, and 4. Suppose you are taking average of this three data, it will become like 1 by 3 multiply 5, because you are taking here some negative. So it will cancel out from this. So to avoid this, what we can do, let's see the PPT again. See, to avoid this, we can square this yp minus y square, then add all the loss, then average this. This is called square mean square error. So now we have this equation yp minus y whole square summation y by n. See, what is yp? We already know what is yp. If you see, yp is basically w naught plus w1x. So if I put this equation becomes this w naught plus w1x minus y whole square. Now my aim is to decrease this loss. My aim is to decrease this loss. If we decrease this loss, this gap will decrease. If the gap will decrease, my equation will be production ready. So how can we decrease this loss? See, in this equation, if you see carefully, we have x and y, and we are not able to change x and y. Why? Because both come from data. So this is come from our client data. So you're not able to change something in x and y. So yeah, we can do some data engineering, but we are not going to change the data. So now in our hand, w naught and w will be there. So using this equation, we can change something. So how can we change? Before that, let's try to implement Python till now. Then we'll go ahead and try to see how can reduce the error. Okay. So see, let me go to the Python and try to implement this. So this here I'm implementing till now till loss using Python. See, I have this data. So this is a very simple data. We have X and Y. Here see some X and Y. Let's try to use this numpy array to make X and Y. Here you can see I'm taking same W0 is equal to 2 and W1 is equal to 1, totally random value, making YP series. So this is the YP here, and we're taking this equation. Okay. If you make into pandas format and just try to see this looks like this, same I put in PPT. So this is the X and this is the real value. This is the prediction using this equation, basically, this equation. So anyway, we are not okay with this equation because this value, W0, W1, we have to change. Now let's calculate the loss, but I just show you in the PPT. So if you see this is the loss 1 upon n summation yp minus y whole square. Same I wrote in Python. And if you see this is the loss, and I want to decrease this loss. But let's plot the loss here of some W0, W1. So what I try to do, I take a range for W0 and W1 value and try to get some loss and try to plot it. See this, our loss looks like this. Okay. So this x-axis is basically W0 and W1. See, we have this loss. This is the W0, W1. Suppose you take a random value of W0, W1. Maybe you take this one. Maybe you take here. Maybe you take here. And whenever you take, your loss will be on a y-axis. Suppose you take here. So maybe your error will be here, right? But there is some value just very near to zero. For that, loss will become almost zero. So not almost zero, minimum, right? It's not possible almost zero. But see, loss will be minimum. So I am looking for this W0 and W1. Okay. So if you take any random value of W0, W1, you will be anywhere in this graph. But our aim is to reach here. And if our aim is basically to find that W0, W1 for this loss will be minimum. So we plot the loss, we got the graph, and now this is our loss function. So this is our loss function, and we want to reduce the loss function. For that, I'm going to use gradient descent. Okay, so let me explain you exactly how gradient descent will work and how can we implement using Python, try to find this loss, minimum loss, and W0, W1 for that loss. Okay, so let's try to see this. Let me go to the paint and let me try to explain you. Okay, let's try to see here. See this. So let's see this. See, just be observe loss function looks like this. Okay, and here your weights. Okay, suppose you take any random value of W0, W1, and you are here for that W0, W1 because we don't know exact W0, W1, so we can take that W0, W1. Our loss will be here. So we can take any random value and suppose we take and we are here. But we want to come from here to here. For that, we are going to use basically our gradient equation. So what is the gradient equation? Gradient equation looks like this. I'm just writing here. W weights is equal to W minus learning rate D loss upon dW. Okay, this is our gradient equation. See, take it granted, learning rate will be positive. A very small number, positive. Okay, so right now just assume it's a positive number. Maybe that is any number 0.001, take very small number. So this is the learning rate. Okay, so just define as a positive number. Now see, suppose we are here. So we have to calculate this D loss by dW. If you calculate this D loss by dW here, see, let's calculate this. We already know in our 10th or maybe 11th maths, uh, d, dy by dx is nothing but slope of that y equation, right? So here you are taking d loss by dw. So this is log's function. This is slope only. So we can find the slope here. Just see, this is the theta. And you can see this theta is basically less than 90, right? Just observe this. It looks less than 90. If it looks less than 90, means tan theta will be positive. If this tan theta will be positive, it means this slope will be positive. If this slope will be positive and I put this, this equation here, if I run this equation here, definitely my W will be decreased. Why W will be decreased? If you have a 5, if just subtract any number from this W, so your 5, now your 5 will be decreased by 4 point something, right? The same way here you can see, I'm just trying to decrease W is equal to W minus learning rate's already positive number. Now we got here it's a positive number. We multiply both positive number, it's a positive number. If you subtract from W, definitely my W will be become little, little small. So what happened here? We start moving left side. Again we run equation here, then again move left side. Again we run equation here, again move left side. So in this way, if we run this equation, W is equal to W minus learning rate E loss upon dW, in a loop, maybe we are able to reach here after some times. And we got this W naught and W1 as our equation will be like this. W naught is equal to W naught minus learning rate D loss by TW naught, and for W1 it's become W1 minus learning rate D loss by dW1. So we will use both this equation. Actually what I did, I put my W naught in this and again W1 in this. So I will run W naught and W1 gradient descent equation in a loop and try to reach here. And after sometimes running the loop, we are able to reach here. So we'll find that W naught W1. And if now plug our X, we are able to predict something. But you can think, so maybe we are here. Maybe we are here because you are taking W naught W1 random value. Suppose you are here using this equation. Is it possible to reach here? No. This is a question. Just try to think. Is it possible to reach here using this equation? Let me clean everything and I will ask this question. Just think for some time. Is it possible or not? So I got some answer. People saying no. Let me explain you whether it's yes or no. Just give me a minute. Okay. So say people are saying, let's just try to see whether all of them correct or not. So let me give me a minute. Okay. So let me plot the loss again. See, this is our loss. Okay. And this is W naught and W1 here. And this is our loss. Right. Once we are taking any random value, any random value. So if you are taking any random value, W naught W1, so maybe you are here. Okay. Now let's try to think whether it's possible to, using that gradient equation, we are able to, go forward or not. So we know for W naught minus learning rate multiply D loss by dw naught. For w1 minus into learning rate, multiply d loss by dw1. See, if you would take your, slope here, just try to see. If you take slope here, this is maybe theta 1. So now my theta 1 will be greater than 90. So if your theta 1 will be greater than 90, definitely your tan theta 1 will be negative right now. Yes, in second coordinate, tan will be negative, right? In second 90 to 180, tan will be negative. Here tan will be positive. So now, if see this, maybe if you are not able to understand y is greater than 90, if you make one line here, sorry, one line here, just see this theta is greater than 90. So if our theta is greater than 90, tan theta will be negative. So if tan theta will be negative, it means slope will be negative. So this thing will be negative now. If it's negative, learning rate is already positive. If you multiply both, we got a negative number and equation will become like this. So now my equation becomes automatically W naught is equal to W naught plus learning rate D loss by dW naught, right? And here it's become W1 is equal to W1 plus learning rate D loss by dW1. So equation is actually changed automatically. You don't have to do anything. You have to write equation only once. According to the data, this equation will automatically modify. Now, if you run this equation, what happens? You start moving right side. So if you start moving right side, after some times, you are able to reach here and you will get your W naught and W1 for that. So we have a minimum loss and we have a W naught and W1 for that minimum loss. So anyway, either you are a left side or right side, if you are using gradient descent for such equation, we are able to reach to the global local minima or global minimum, because here there is no minimum, only one minimum. So you can say it's a global minima. So we are able to reach that point and we are able to find our W0 or W1. But here I'm trying to explain this gradient descent using theoretical and graphical method. But if you want to write a Python code, definitely we need some other approach, right? Where I just try to explain you how gradient work basically. And I believe you guys are able to understand. If anyone have any doubt till now, please let me know. After that, I will explain you how to write a code in Python for this. So if anyone feel any doubt till now, just let me know. What is learning rate? Okay, let me explain you what is learning rate. Just a minute. See, someone asked what is learning rate. Just 1 minute. Let me delete this, and I will going to explain you what is learning rate. See, someone asked this question. We know in our equation this is W is equal to W minus learning rate E loss by dW. See, N is number of data. N is just number of data. Here D, this is loss, this is weights, and in our loss, if you see, we write 1 upon N summation YP minus Y whole square. This N is nothing but number of data available, not feature data. How much data available? Because average, we're taking average. See what is learning rate. If you see, this is our graph. Okay. Okay, thank you. Let's see what is learning rate. See, if you are taking the slope, maybe your slope is very small here. Maybe again you're taking a slope will become very small. So if your slope become very small, you will move very slowly towards your aim. Okay, very slowly. So this if it is very small, okay. Sometimes maybe it's high also, maybe some high value. Suppose some high value, okay, and maybe your loss function looks like maybe maybe like this also, okay. So this is another case. This is another case. This is some local minima, and So how can we use learning rate? Here we can tune on learning rate to avoid this. Suppose you are, you're coming like this, coming like this, coming like this. Then you reach here, it start moving like this because he thinks this is the minimum point because your equation defined like this. So if you go here, it start moving like again this side, right? To avoid this, we can increase the learning rate and maybe he can move directly from here to here. Okay, we can increase the learning rate. So learning rate is basically we have to tune. If you don't tune the learning rate, because this is also random value, we don't know what exactly learning rate will be there. Ideally, we try to take very small value, but we have to tune sometimes. Okay, because maybe your loss function, your gradient will sit somewhere. Okay, so using this learning rate, we can increase the slope, or we can not a slope. Actually, we can say step, not slope. Slope we can't change, no. But multiply with slope with learning rate, we can change the step. How we are taking fast step or little smaller step. Little, the lower step or maybe little higher step. Are you getting my point? How can we, change the using this, learning rate? We can change these steps. Okay. Thank you. Thank you, Tanju. Thank you. Okay. So now let's try to implement this in Python because till now we are able to see how can we are able to understand the gradient descent theoretically. But let's see how can implement this in Python. Till now, if anyone any doubt, please let me know. Okay, let's go. How can we implement this in Python? See, very simple actually. Let me write here loss equation. This loss equation, basically, error you can see write anything. 1 upon n summation w naught plus w1 x minus y whole square. Okay. Thank you so much, Manohar. Thank you. So say this is the loss function and we're trying to reduce this loss function using Python. So we already know in Python we are able to write this equation. There is nothing, much technical this in this. What we have to do, w is equal to w minus lr into d loss by dw. But we have to find this value because learning rate is any constant, any variable. We can give the variable and multiply this. But we have to find this value. So how can we find this? Using this equation only. See how can we do this? Suppose we want this term, d loss dw naught. Let's try to differentiate this 1 upon n. Let's try to recall your 11th, 12th math. You have y is equal to x square, dy is equal to dex is 2 into x. How it's happened? Actually, x to the power n, if you differentiate this, it will become n multiply x to the power n minus 1. This is very simple. I think you guys already know in your 10th, 11th maths, right? So I'm trying to use this here. So let me use this. What happened? 2 will come here, right? And this equation become like this summation w naught plus w1x minus y. See, we have to do this again for this one. If you do, it's become like 2 upon n. See, if you do this d upon dw naught for w naught, it will become 1. For rest of all, it's become 0, right? Now it's become 1 plus 0. So this will become actually 2 upon n. Are you getting my point, all of you, or not? I think I put it in fast. Let me explain you how it's working. Maybe some of you are not able to recall it, your class 11th math. Let me recall this. Give me 1 minute. Yes, see. Suppose you have a function y is equal to x to the power n. Okay. So how can we do this? If you write dy by dx, equation will be like this. N x to the power n minus 1. Suppose x is another function. Here you can see this is not x, this is another function. Then what happened? This equation little modify. How it's solved? Let me explain that also. If you have y is equal to fx to the power n, so now this equation become like this. N fx to the power n minus 1 d by dx fx. So I have to use this equation only. Okay. because we have fx, not only x. This is w naught, not only w naught. This is fw naught. This is like this. So I'm going to use this one. Very simple math. Don't worry if you don't. Just try to follow me. If you're not able to understand, don't worry. I am just deriving this for using an equation. So if you do this, 2 will come here. This become 2 upon n. This will become like similar w naught plus w1 x minus y. Now we have another d upon dw naught for what? W naught plus w1 x minus y. I'm writing here 2 upon n. See, this is basically again yp. So I'm writing this yp minus y. And here you can see for w naught, it's become 1. For plus 0 plus 0, this has become 1. If you multiply with whole with 1, actually this become 2 upon n summation yp minus y. So this is my loss differentiation with respect to w naught. Please try to recall this. I'm using this equation only in our Python program. Okay, please try to recall this. Maybe that equation will not change. That loss value will be changed. Okay, are you getting my point? This equation will be similar. We are not going to change this equation on each point, but yeah, this loss value will be changed. Okay, don't worry. I'm coming in Python, so you are able to understand this. You have a valid point. Just give me some minute. Just trying to let me derive with respect to W1 also, and you are able to understand. Okay, just please give me some time. So here you guys say d loss by dw naught, and we got 2 upon n by p minus y. Now let's try to again do this with respect to w1. So now it's become d loss dw1. If you're doing for dw1, 2 will come here. So become 2 upon n summation w naught plus w1 x minus y b upon dw1 w1 plus w1 x minus y. Again, this term become what? Yp minus y. And see, if you do this differentiation with respect to dw1, what happened? This will become 0. This will become 0. Here we got x only. So that's why if you d loss by dw1, it's become x will be here 2 upon n summation, not x will be here, sorry, summation yp minus y into x. See, if you compare with previous one, dw naught, only x will be not there. But d loss by dw naught. But d loss by dw1, x will be there. This is only changes. Don't worry, I'm going to write this in Python only. So till now, I'm trying to explain you how can derive this. Now let's try to implement this in Python. Even if you have doubt, let me know. Otherwise, let's try to go to Jupyter Notebook and let's try to implement all these things. What we do. Okay, thank you, David. Okay, so let's go to the the notebook and try to implement this all the things what will be there in Python. Okay, give me a minute, please. Yeah. So let me know whether it's visible or not. My Jupyter notebook, is it visible to all of you? Anyone of you? Is it visible? This Python. Okay, thank you all of you. Thank you so much. Okay. So see here you can see I'm just in, I believe you guys have some basic knowledge of Python. Even you don't have, don't worry, we are not going to teach Python here. I'm explaining you how to implement gradient descent. Okay. So if you don't have Python background, don't worry. If you have, enjoy this. If you don't have, don't worry, because I am only looking to teach you how this machine learning is working, right, on data. Only this is my aim. If you know Python, enjoy. If you don't have, just be patient. Try to think. Only within 5 minutes, I'm able to complete this part, and then I will explain you how this works. Yes, yes, I will share. Don't worry. I will share. Don't worry. Don't worry. Okay, so let me import this pandas. See, this is the data. So I'm reading this data. Here we have data x and y. Now what I'm trying to do, I'm just separating this x and y in other variable. So in x I'm putting x, and in y I'm putting y. I'm just taking this x in a variable name x and this data in variable name y. Then I'm converting into numpy array. Why numpy array? Because if you convert into numpy array, your equation will be, the equation become easy. That's I'm just using numpy array, don't worry. So now I'm converted in numpy array. I'm taking any random value w0 w1. See, this is my yp and this is my yp. Okay, so for each, for 3 our real value is 8.5, but prediction is 5. Why 5? Because you are taking any random value. So okay, I'm not converting in pandas again because I already show you how to convert this pandas. So just for time being, I want to show something else. Not I already show you this graph, this error graph. So now we're not going to run this. I want to show something new. See, this is the plot I want to show you. See, in red color I have this line that is between my real x and y. In green color I have a plot between our x and prediction. See, there is a gap between real value and prediction, and I want to decrease this gap. We already talked about how can we decrease this using gradient descent only. Now let's try to do in Python. So just to remember, this red value is basically x and y, graph between x and y, this graph between x and our prediction. So I want, like such a yp that maybe it will overlap, or maybe green, line will be very near to red line. See, I wrote here, prediction equation. Don't worry, I will explain you how. See the gradient descent equation, and if you check this, just a minute. See this. I explain you how it's working. Even I, run it. Don't worry. See, slow. This is our y and yp. Sorry, x and yp graph. This is x and y. And see, slowly, my machine is training. Basically, my machine is learning. That is basically the machine learning. So my gradient is learning, you can say, and slowly we are trying to reach to the real value. Okay, how we are doing this? Just very simple equation. The same equation. What I did, I take any random value w0 w1 learning rate. I told you learning rate is very small. Just you have to tune maybe. I take this because definitely I run 2-3 times and then I find the learning rate. See, I wrote this equation 100 times. Maybe you can go little lesser also. Let's go for 50 times. Okay, no problem. And then what I did, I write this yp is equal to w0 w. Very simple, no code, no fancy code, very simple code. So all can able to understand. Very, if you learn Python only, don't have any work experience, still you are able to, understand this. Okay, see this k I am taking to write while loop. So I took k is equal to 0 and take k less than 50. So I will run this while loop 50 times. Okay, are you getting your point? K is very simple. I took k is equal to 0, and then because I want to write while loop 50 times. Okay, now here you can say I write k is equal to k plus 1. So each time this k will increase. Right. No, intercept, not intercept. Intercept is W0. Intercept is W0. Okay. Mayank Gupta, please see carefully. W0 is intercept. K I am taking for counter. Yes, and yes. Sandeep is correct. Counter. So while loop will go for 50 times. Good man. Man. Okay, thank you, man. Thank you. Yes, it's the count. Yes. Just writing k is equal to 0 to run while loop. I write k is equal to 0. Then I take any random value for W0, W1, learning rate. While k is less than 50, I put this equation yp is equal to w0 w1 plus w1x with this. Then calculate the loss function, even print the loss function. Then I wrote this gradient equation w is equal to w0 minus learning rate d loss by dw. Just I proved this equation. How will I get 2 upon n multiply summation yp minus y? I just derived this. Again for w1, I also derived this equation also. D loss by dw1, that is become 2 upon n summation yp minus y multiply x. Then I try to plot each time. So let's run this. See, first my loss is 152. Now it's become 137. See, when we are trying to reach to the minima side. That's why my loss will continuously decreasing. See, till 1.4. First, our YP and X relation is this. Slowly, we are reaching till here. If you make 100 times, maybe you are very near to this. That's become overfit, But I'm not coming to overfit and underfit because there's a totally, different story. Here I'm trying to teach you gradient descent, and I believe you guys are able to understand how gradient work, how we are able to minimize our loss, and how to optimize W naught W1. You know, if you see the W naught W1 value, this is this 0.53, 2.25. And what it took in starting, we took 0.1 W naught, and W1 is 0.01. Now our value become 0.53 and 2.2 something. So how it's possible? Because you use the gradient each time it will iterate, it will update the W naught W1. Again, we write the equation, calculate the loss. Again, we try to use gradient. Every time you use gradient, definitely you got some other W naught W1, and you try to reach to the minima side. So I believe your guys are able to understand. But still, anyone has any doubt anywhere in this whole session, please let me know. Are you guys able to understand how this gradient works? You can take any name YP. There is nothing purpose of YP. I'm just taking YP as a prediction, but you can take it. No, see, gradient descent is not we are using optimization image classification. We are using something different. What is that? See, for image, the things will be totally changed. Okay. For image, the CNN we applied. In CNN conditional neural network, first we have convolution. After the convolution, we are using fully connected neural network. For fully connected neural network, definitely things will be totally changed. Okay. So definitely we are using ADAM sometimes. And there are different learning techniques like RGB, different. So momentum based gradient descent. Mostly people are using ADAM nowadays. Okay, but those are totally different. But yeah, for ADAM, so fundamental will be gradient descent, right? So whosoever asks image classification, in image classification we are not using gradient descent. Yeah, gradient will be fundamental for that, but we are using ADAM. Even in a deep neural network, we are using ADAM. Yeah, not only people using a different.
Sorry to interrupt you, sir. So we are at the end of the session. So before we proceed to answer your question, audience, I would like you to request the attendees to please fill in the poll about the feedback, as it helps us to conduct most of the sessions, and we will be taking the Q&A now if Atma sir is uh, comfortable with it. So can we start the Q&A, sir?
Yes.
Okay. So meanwhile, audience, you can fill up the feedback poll.
See, okay, please guys fill the audience both. But anyway, between someone asked what is the difference between Y and YP. See, Y I'm taking for a real value. Like we already have the dependent dependent variable. See, we have dependent and independent variable. So that dependent variable I'm taking as name Y. And you can take YP also. YP will be our prediction, the equation name. There is no need to write YP, you can write any name. Okay. Then I'm just taking YP because it looks like prediction. People generally for prediction, writing YP. That's why I wrote YP. But you can write anything. It's not a necessity. So a variable only. A variable you can take any name. Loss, no, the loss function will be also not same for every problem. See, suppose your problem is image problem. Right now, someone asked also, but that is not a loss function. Right now, I'm talking about loss function is MSC loss. This is a mean square error loss. So I try to use gradient descent. For if you have a different loss function, will be totally change. Loss function can be changed. Okay, Chanda. So it totally depends on the problem. Yes, YP is prediction. Yes. Oh, thank you, Chanda. Thank you. So that is totally a different, topic you are asking. Loss will can change for, yeah. See, this loss we generally use for regression line equation. Okay, okay.
So, sir, we have two questions in Q&A section. So, one is asking, what is vanishing gradient problem? How is it critical while choosing a learning rate to converge on a global optima?
Okay, see, this is a vanish. See, vanish gradient is not. Let me explain you what is this. See, generally, if you are working on RNN model, RNN means recurrent neural network. Okay, so what happened in neural network, a recurrent neural network? We have network like this. If you have idea of RNN, then you are able to understand. So in RNN, our model looks like this. So what happen if you want to calculate loss here? This loss will actually go till here. Sorry, go till here like this, because these are all the points. In gradient, we are taking only one equation here in gradient right now, but in the RNN, this equation will calculated here. Maybe equation will change. Definitely, there will be some non-linearity also. I don't know whether you know RNN or not. So RNN will calculate it for each neural network. These are neurons on. Okay. So what happens if you calculate D loss, basically the gradient, maybe your loss will become low. Maybe here low, again low. So it's coming low, 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 low. Sometimes over here it almost become zero. Almost. It's not possible to become zero. Maybe it become very, very small. So what happens if it become very, 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 very small? So let's compare to its zero. So if it's zero, what happens? See, just see like this. Learning rate D loss by dw naught. If this becomes zero, what happened? W is equal to W. Always W is equal to W. There is no learning because D loss by dw is zero. So this is your vanishing gradient. Gradient is total vanish. Okay. So we generally try to, for avoiding this, what we use? Use LSTM for that. Right. So in RNN, we have GRU and GRU and LSTM. But here in this particular webinar, I'm not talking about LSTM because it's a totally different topic. Even if I want to talk LSTM, I believe you guys already have a neural network idea. Then I can discuss only this type of thing. They're very, very advanced. Okay.
So, sir,
Now
next
what is second?
question. Yeah, so
Yes.
sorry to interrupt, sir. So, next question is from Sabri. So, he's asking that how to choose LR if there are many minimas for the loss.
Right, that's a very good question. Actually, see, very difficult to say what is the learning rate. See, if you have lots of local minima or maybe global minima, we can't say what is the learning rate 0.0001. No. See, we have to do some iteration. Let me explain you in our own problem. Go here. Suppose I take maybe here. Let's go here. Let's take maybe uh, 0.1. The 0.2. See what happened. I took 0.2 learning rate. Our loss start increasing. It's not decreasing. It's start increasing. See our loss, and that's why we are moving away from the line. Here you can see we are moving away from the line because we take any random loss learning rate. That's why we have to take first as small as possible. Like I'm taking very small. See, but see if you take very small, what happened? We are learning, but very slow learning. See here, first loss will be like this 0.1278. Here you can see now it's become 7. So it will small, definitely it will be small. See, we start moving towards here, but very slowly because our learning rate is very, very small. That's why if you take very high learning rate, maybe you are going away from the minima. If you take very high, very low learning rate, you go very slow. Let me write here 5,000. And now if you run 5,000, maybe it will take some time. So you will have the better understanding. See, we are decreasing. Our loss is decreasing, but very, very slow. See, it's very, very slow, right? For 50, now it's become 49, it's become 40. See, it's very, very slow. If you see the plot here, let me see the plot here, how slow we are, you are trying to reach towards this. So that's why there is no, exact method to find the learning rate. Like we don't have any equation to find the learning rate. We can take like now we are able to find, we can't take 0.1, we can't take this. Now we can start increasing. So maybe you can increase to, now you can see start decreasing, just getting faster. Now even you can, if you want to decrease, you can decrease that. So in this way, we can, take. There is no exact method for that. Are you getting my point? There is no exact method. Yeah, definitely. We can do 2, 3 iteration, and then we are able to find, oh, maybe this is the learning rate. It will work for our data.
So, sir, I
Got
think
it?
we are done with Q&A. I think there are
Okay.
no more questions from the
Okay.
audience.
Okay. Thank you.
So, thanks a lot, sir, on behalf of Analytics Vidya. So I would like
So
to thank you for your time and for delivering such a
LinkedIn
wonderful
profile,
session.
just search Atmakumar on LinkedIn, you'll find the.
Okay, sir. So I will be sharing the LinkedIn profile in the chat. So,
Okay, thank
yeah. So, sir, first of all, I would like to thank you for your time and for delivering such a wonderful session. So, I am
thank you.
sure our audience found it insightful, and hopefully, we can conduct more such sessions with you in the future.
Thank you.
And talking about the LinkedIn profile, so audience, I am sharing the chat section. You can connect with sir by following the link. And I hope everyone has filled up the feedback poll. If not, I request you to please do so, as feedback is valuable and help us to conduct more such knowledgeable sessions. And the recording of this session will be available within 2 days on our YouTube channel. The link you can find in the chat section. And we will be back with another session of the data hour tomorrow. So the link of the upcoming sessions are in the chat section. Till then, bye bye and keep learning. So thank you, sir.
Thank you all, guys. Thank you so much.